Yeah, Matus, how about your research question? Is this making progress? I mean, the idea you have raised is not bad, I'd say. Have you been
Really?
in touch with Jay?
Yeah. I reached out to Jay, and yeah, I'm just talking to him about the kind of level of support I would need. I need to reply to him, and I also talked to Jan about this, this idea. But apparently, Jan said something along the lines that it's not really in line with the kind of the rules of the exercise, because we don't have the relevant data for that. But I still think that it could be like this method could be used in the real world.
Yeah, of course. It's we need additional data that is then available on chain, and it's not building on the data set we have from Gitcoin Grants, since they are just measuring the contributions that went to Gitcoin Grants. But in general, I wouldn't limit it to this particular data set we have.
Okay. Well, yeah. So I'm looking at what Jay said, and basically, he says that it's going to be expensive to gather all that data. So he's asking me about my budget. Yeah, I'll just revisit it. I'll just like try to wrap my head around it, but I'll try to be ready for next Tuesday.
Yeah, and even, I mean, I think even if it turns out to be not feasible, it would be interesting. Okay, where are the obstacles? What's the problem here, and so on. So,
Okay.
as discussed in the last academic session, it's not only about successes; it's also about failures or dead ends. That's totally all right.
Okay. Well, then that makes my task much easier.
Yeah. Okay.
Okay.
Yeah, and today I was briefly in touch with. Oh my God, too many channels, too many conversations. Yeah, I was briefly in touch with Joe on what's going on in the current round, and there are really some little bit weird things going on. For example, I get like bot contributions, same user, same amount. Um, 10 contributions, or let's say 5 contributions in a row, but not immediately one after the other, but sometimes 1 hour in between. But it's really a weird pattern. So I have the feeling there's some weird things going on in the current round. And he also wanted to share some latest insights. So I'm not sure, either he'll join today or we will get some fresh insights on Thursday in the academic sessions. But yeah,
Okay. It'd be
also
interesting.
keen to learn more here. Good. I think we should give it another couple of minutes to make sure that the rest of the group is able to join. Yeah. Any other news from your side while we are waiting?
From my side?
Whatever. Who else? Whoever.
Well, I don't know. I mean, I can say for OV that the market is really crazy, and I don't know, kind of like valuations are through the roof. Everyone is throwing money at things. So I was wondering what people think, how long this can be sustained. Like, aren't we kind of overshooting a bit? Like,
It's really crazy at the moment. Nevertheless, I feel that there's a lot of new money coming in. So new participants, new investors. So I
definitely.
guess, yeah, for Outlier, it's also, I guess, let's say some new co-investors are knocking at your door. People who haven't been active in crypto that much or not at all.
Yeah,
What
it's
does it?
mostly it's mostly kind of maybe famous people and artists kind of looking into different ways to leverage the technology to solve their pain points. So we have a lot of
Okay,
projects that focus on
interesting.
music, on kind of like uh fixing what's wrong with the music industry, as in like fairer distribution of royalties, and things like that. So it's mostly these people, but then yeah,
Mhm.
traditional investors, they are interested in this as well, because I don't know, I feel like they need to deploy money somewhere, and everyone is worried about inflation. So that's
Yeah.
the kind of the main Bitcoin narrative. So
Mm.
yeah.
Yeah, exciting times. So, I mean, in one way, this is great because there's much more funding available for all the builders in the space. On the other hand, of course, it can also be a destruction to, I mean, last year, 2020 was certainly for token engineering, for example, really, we have been making great progress because everybody was super concentrated on what needs to be done. And now, of course, there's a lot of distraction on hype here, hype there.
Yeah, that's definitely a problem.
And so, would you say you get more applications for your Bandcamp program or less because everyone is, well, no problem to raise money elsewhere?
I would say it's more actually,
Mhm.
because I think it's people who during bear market did not think of doing a blockchain project, or raising money via a token, or deploying a token. Now everyone wants to do it, and compared to 2017, I think people are much better at knowing what you can actually use it for and what you can't. So
Mm,
back in 2017, there was a lot of like crazy ideas that, like, very unlikely to work with a token,
mm.
or the token would only add like marginal functionalities. Whereas now, I feel like, yeah, it's more, and people actually know what to use it for.
Okay, maybe for, I don't know if everyone knows the Outlier Bandcamp program. Can say some words about that.
Yeah, yeah, sure. So we have two accelerator programs. One is called Basecamp, and the other is called Ascend. So kind of the idea is that you start at the bottom, the base, and then you kind of try to make it to the top. So Basecamp is really about kind of it's usually 2-3 month program to make sure that projects have everything covered in terms of token design, token allocation, fundraising, tech, community building, and all the things that you kind of that you need to make your project successful. And then we have Ascend, which is kind of focused more on the token itself. So it kind of goes deeper into token design, and that's where we would like to leverage this common knowledge of like like what you guys do, like token engineering, to really kind of add value and help projects deploy a token that makes sense and really kind of achieves the core objectives of the network. So that's the kind of how the general idea.
Okay, cool. Maybe we should talk in a separate round on TE Academy and this program.
Oh yeah,
There
definitely,
might be some good synergies, I guess.
definitely. Definitely. We are like now thinking very hard how to improve or like maximize the value that we can add in
Yeah,
Ascend, the kind of token focused part. So that would be really helpful. Thank you.
helping you. All right, now, okay, let's briefly check the agenda because obviously today is the day of changes and unexpected um, yeah, obstacles. So we were planning to have updates from Irvin, Jay, and Andrew. Now, Andrew popped up in the call, but obviously dropped again. So he isn't here at the moment. Um, Irvin is in the call. However, he's in the call for recording only since he had to jump off for an urgent developer meeting. He would love to share his talk about behavioral economics and behavioral game theory, which I'm pretty excited about. He will record it and share it asynchronously so that we can take a look at it. And so this is also, you have to remove it from the agenda. And then last but not least, Jay, I was expecting he's providing us an update on grants round 9, fresh from the chain, but obviously he isn't here as well. All right, now, maybe then we could just start with, should we just switch to a hacking session to the machine learning topic, Mark and Jan?
From my side, it's fine. Yeah.
Yeah,
If we
okay.
don't have anything else, I mean, like I did have some questions
Mhm.
that might be helpful, let's say, but maybe Sean would be the best person to answer them, or maybe also you, Angela, or Mark, or whoever, because it has to do
Let's
with
try.
building the. Yeah. Let's see. I can share my screen.
Let's check.
Let's do it.
Not yet. Okay.
So yeah. Let's see. So what I was trying to do is to add a new notebook to the whole
Mhm.
GitHub on the Gitcoin model and
Mhm.
integrate just different things that we worked on so far. And one thing that I noticed, let's say, is that there was an update from pickle.gz, like the extension was changed. So for
Mhm.
example, let's say if I run it like this, which is the old version,
Mhm.
says it says
No module.
that's not the issue. Like the issue is that the file is gone.
Okay.
So then I basically just did this, right? Like the change the file, and then it finds it, right? But then there is the pickling, right? So there is some issue then with this method. So this is something that I bumped into because I wanted to load the actual Gitcoin grants data, right? Like not the cadCAD model data, which is basically the result, but I kind of wanted to see the structure and then apply the same structure so I can basically create the network X objects, right? So this is like
Was
one bug that I found.
was this pick created by Danilo and provided by Block.Science, or was it Sean?
No, it's Danilo. So what happened, I
Okay.
can show it here. So it's
Mm-hmm.
here. So for example, change.xz to .tar.xz, right? So before, let's say, the model results used to be .xz, right? But now it's .tar.xz. That's basically also what I did this here, right? So before it was a pickle.gz,
Yeah,
and that loaded correctly here, right?
but the
But
new one
now,
doesn't.
yes, yes. So that's kind of the point because apparently there was like a so this This is something that Danilo added. So that's kind of the update. But
okay, so sorry.
So like that's also, I mean, like I noticed that, but it also didn't stop me with like just proceeding, because then I just found some other notebooks where it was kind of like I had a preview of it, so I couldn't load it. I couldn't also rerun it because I found another bug. But now I just continued. So I was just wondering whether somebody in the group encountered the same issue. Because also like figuring out this thing, load key, it's quite a tricky error. When I was like, yeah, just yep.
I haven't experienced this, but I think it would be good to let Danilo know and just ask for if there's a quick fix or what's the root cause here, and just tag him in the message so that he's aware that there's something. Yeah, probably it's just a tiny note.
I'm going to jump in here because should definitely do a GitHub issue, but my student was trying to make the .exe extension work and ran into issues, and then changing it to tar.exe worked. So we had the exact opposite problem, and that's why we requested that change. So if it's breaking something, we can definitely unrequest it and investigate.
That's interesting. So I mean, it's possibly just some addition here, but like I was basically going into the Cloud Pickle library, and also like the Pickle, which is kind of like like Cloud Pickle has some more additional things than Pickle library and so on, and just tried some other methods to open this up, right? But I couldn't. So maybe I should just ping Danilo and go with that, right?
Yeah, both routes are fine. I mean, for tiny things, could be you can drop a note in the channel. You can also open up an issue on GitHub. Both routes are fine.
Okay. So other than that, yeah, like I just replicated like all of the things. For example, adding the round number to the contributions data. That's nothing new. And then I also used the code from Sean for visualizing the graphs, right? So this is, in the end, it's kind of creating like a graph from all of the for each row, right? Which each row is a contribution, and then I'm just able to visualize this. This is basically like one combo, right? But then like we can go further and just you can see different ones. So this is, for example, a grant. This is a contributor, and then we can see who contributed to what, and then we can basically just change it.
What was the default again?
The default?
Yeah, default 80. What is it?
It's a time step.
This base.
It's a time step.
Yes.
Okay.
The only thing is that I noticed that when Sean was working on this, it was building up the graph, right? So
I was just wondering.
Yeah, so that's one thing, right? So here we can just see individual ones. So it's not building up over time. So that's something that I need to investigate.
I think, Jan, you picked his code from his let's say his reply in the Gitcoin Discord, because I think he made a special branch in his GitHub account. There you can see, or you can look at how he constructed this graph, this simulation graph that it grows over time. I think it's in his GitHub somewhere in some branch. I haven't checked it out yet.
It's here. Is this one? So this is basically it. So like I basically just copied the updated version.
I think you need to have the other ones as well. So basically the last three code snippets, maybe. I'm not sure, right? But
and it's the same thing. So basically, let's say I just copied these two, right? say these two.
Yeah.
Then I basically just ran this, but I needed to change. He ran the map function on the result, basically the contributions to graph. Ran the same thing, but I basically did a list comprehension, and then this is pretty much the same code, right? So this basically this, right? Basically this part, and
I think
this
Sean,
part. Yeah,
Sean left out his secret sauce, I guess.
I mean,
you removed it before committing.
Yeah, I think so.
I mean, the reason is that like I cannot see the structure right here, the result, because it's like just wanted to replicate the cadCAD model, right? Results, because that's what he's using, right? And then if I replicate that, then this should work. So that's why the result part is important, because then I can see how to replicate the empirical data, right? So that's why I took quite some time on this part.
Okay, I think we have to ask Octopus or Andrew to set the default back of the pickle file. Andrew?
Yeah.
So .xz is not on a Mac or something else. It's not that easily decompresses. I actually requested that it be changed to a tar.gz file, which would have involved recompressing it in a more standard format that's more easily accessible. Actually, my request was that the uncompressed file be made available. It's only 6.5 megabytes. Too bad to download it. And then you could just download the .csv file directly and you wouldn't have to pickle. The comment from Block.Science was they didn't want uncompressed data because it grew too quickly. So they changed it from .xz to tar.xz, which appears to have broken.
It's 70K rows as far as I know. The contribution, so it's not like a huge, and as you said, it's 6 mega, right? So not that much. And other than that, yeah, like let's just comment this. Let's go into the steps then of visualizing that. That's the next step. Yeah. So that I'm working on at the moment. Yeah.
Sorry, I'm not trying to dominate this conversation, but I have an easy solution. I can just do a GitHub repo where I host the uncompressed data, and then you can pull it directly from there as a CSV file. Deal with the pickling.
We can basically do that as well. Yeah.
Typically, you pickle huge things, and this doesn't feel like it's big enough to pickle.
I do agree. Although, let's say, but okay. So does the run simulation part work for you?
So I mean, I can get the data into a pandas data frame from the .csv file, and I haven't tried to use any of the cadCAD stuff.
Okay. I see. Okay, so I mean, it's from my side, that's the next step to be able to open up the result part, to continue then with figuring out how to structure the contribution data frame, so we can plot this over time, right? And then continue with embedding the empirical data into the node2vec embedding. That's the idea behind all of this. Is anyone that would like to work with this on me, like for example Mark or whoever else, like that can basically maybe pick up part of this? Yeah.
As a matter of fact, I had some time left today to work on it, and I didn't encounter your issue, but maybe I found another data set from your earlier notebook. I think I sent you a DM that I found a bug in your notebook. At least it was for me a bug. But I was working on it, and I used, let's say, this data set. Maybe I can share my screen.
Yeah, sure.
How do I do that again? Here.
Go ahead.
This looks familiar to you, Jan. This is your old, I think your old notebook. Can you see it? Yeah. Basically, I used, let's see, this one. And that seems to work.
Yes.
So maybe this,
I mean,
this is an old one, but I think it's the same data. You're looking at it. And it's the tar.exe extension.
No, it's a different thing. So you were talking about the contributions data frame. I'm talking about the result data frame of the cadCAD model.
Okay, yeah,
so
that one. Sorry, yeah.
So and the error that you got was because of the thing below. So you have the time zone part there, right?
Yeah.
And I tried to take away the time zone.
Yeah, I did this hack for it, and that worked.
Yeah, exactly. Or yeah, it's
because I was wrestling with it, and yeah. So basically, I was looking at this just at not at the result, because the results comes later for me. Just want to take a look at the round data in order to let's see, get some dynamic result in how these grants and contributors evolve over time. Just looking at the raw data, not pulling them through some cadCAD model first, but later on maybe. I did find some interesting library. Maybe Angela, can I share that, or because Andrew is now in the room, maybe it's time for him to take the floor.
I think if that's okay for everyone, I would just continue for, let's say, have 30% for the 3 topics. 30% machine learning update, 30% Andrew math working group, and 30% for Jay with updates on the on-chain data. And yeah, so we would have definitely another 10 minutes to look at your results. No problem.
Well, okay, thanks. Basically, I don't have any results yet, but I did.
Or starting points, whatever.
This is the hacking part. I did find some interesting stuff about graph databases, and in order to to have different perspectives on the same data, I think it would be nice to use some sort of graph database, or at least some sort of repository that we can hold some data in memory or something like that. So I was going down that path, and I noticed an interesting thing about the integration between a graph database like Neo4j, that's the most familiar or the most known graph database, and the Network X graphing library. So what I did, I found an article here, and I need to share my screen, I think, the whole way. Let's do that again. So this is what I found on the internet, the Network X API for Neo4j. And that would come in handy because this library is wrapped with some sort of let's say usual suspect algorithms, which is used in the Neo4j graph database as well. So you can have an easy entrance. It's just very straightforward. I will put this link in the Discord later on. You first have to install your Neo4j database. So I did that, and you need to have some sort of connection, of course. here's the interesting part. You can have a direct link with the driver to your graph database, so you can actually hold your data of the Gitcoin rounds all in one database and then manipulate and view it. Um, as I noticed that Network X does, of course, have also some sort of viewing and drawing capabilities, but for the data manipulation within graphs, maybe you can find other algorithms that will help you ease your job. So I think this might come in handy. I haven't tried it yet, but basically it's about using this library just like a Network X thing to add nodes and edges, but you do it directly in the database itself. And you can draw some nice pictures, of course, but basically that's all kind of stuff that Network X already does as a default. But here's the interesting part. Um, there are some built-in datasets to play with, so you can do that, of course. But this is the graph data science part is the interesting part. So you can use several algorithms to let go or let loose on your data or on your graph data. So so you can have a page rank algorithms and a between a centrality, close a centrality. I haven't figured it out what it means yet, but I think we can use that to have these kinds of, let's say, already default algorithms put on this raw data, time step for time step, and see how it changes or how that evolves. And maybe we can draw some conclusions of that raw data and what's happening, besides what Jan is proposing to do a node to vec kind of thing. So we have several algorithms to our disposal in order to take a look at how this raw data or how this contribution grant relationship evolves over time. Maybe it comes in handy, maybe not. I don't know yet, but this is what I was hacking about.
Okay, so you would.
Yeah.
I just wonder, is it just okay, let's try if these libraries or algorithms will, let's say, um, show some interesting results, or do you already have some hypotheses or directions?
Yeah, I did have some hypothesis that I think you have clusters of 3 groups: the early adopters or the first going to the party. And I think Angela, you mentioned something like that that this kind of pattern showed in the early days of round 9 already. So these are well, this cluster are contributors who are going early in, and they might have some effect on the late followers or something like that, and strategic behavior, seeking alliance contributors. And so I do think that these algorithms will help answer my research question one way or the other, but I'm not sure. That's my hypothesis. Yeah.
Mark, basically just one comment. Check whether there is, let's say, because the Telegraph library already has like a lot of these things, right? For example, for the betweenness and so on, all of these things are in Network X. Like you can calculate all of those things in Network X. And for the community detection and so many other algorithms, like that's already embedded in Telegraph. And like
sure. Yeah, I do understand that there are lots of algorithms already around, but it was just a way for me to figure out, okay, how can we make some integration between a graph database to just collect all these things and just manipulate it around, next to of course what's already around in Network X or other libraries. So it was just an endeavor for me to see, okay, what is possible for this and what is usable for me, and not coming from a background of data scientist, but I do have some knowledge about databases. So it's basically there are more ways to roam, I would say.
Yes. Definitely agree. Sounds good.
So I'm not suggesting you should take that, but it's just for me, a way to look around for solutions that I can understand.
Yeah, cool. And maybe that's I was still this sparked off some more thoughts on. We had this discussion on how early contributors might influence others, the late contributors, and then this impact on the rich getting richer, the Matthew effect. I think that's also a topic for behavioral economics, since I don't know if you all have taken a look at the current round, the way a grant is presented, and there are some interesting and new graphics, like a curve where you see, okay, for $1 contribution, you get that much additional matching funds. But honestly, now I'm taking part since a couple of rounds, and I don't get the numbers there. It's really funny. Also, this is how much the grant has collected yet, and this is how much the matching funds will be. These are a little bit weird numbers in this round, and of course, this is having an impact on what people, or presumably this is going to have an impact on how people behave. And of course, that's something that is almost impossible to measure. But there are some, I'd say, round by round, and particularly in this round, some funny things emerging. So, Jay, since maybe I'll briefly wrap up or repeat what I had in mind in the beginning. So I was in touch with Joe, and Joe would like to share, I guess this will be on Friday, academic session, I will let you know, some latest data they have at Gitcoin Grants, and they have obviously some interesting observations for this round. And now I was wondering if you already got some data, Mark, Jan, perhaps we can move on with this topic, since this is also relevant for your group.
Sounds good.
Yeah, sure.
Yeah, Jay, are there any news from your side? Have you been able to collect some data on this current round?
Yes, I have. I was hoping to announce it today or share it today. It's taking a little bit longer than I thought, but I can share my screen and show you progress if that's okay.
Yeah, let's go.
So hopefully I can figure out how to share my screen this time. Are you seeing my screen?
Yes, we can. Presentation. Yeah, now. Mm-hmm.
Okay, sure. So last time I shared my work, I was showing you how we can collect data using a command line application. So what we did this week is we kind of used that command line to build a website to pull together some of this Gitcoin grant data. So we call it, the website's called tokenomics.io, and I'll share this later. But I'm saying that we're permissionlessly not affiliated, because that's something that's always been really important to me, is that people can get this data even without asking for it, because we have direct access into the node software. So we have a GitHub repo, and I apologize for the halting nature of my presentation. I didn't even know I was going to share this today, but I'm just
Yeah, thanks for doing this anyway.
I'm just going for it. So we have a website, or a GitHub repo called tokenomics.io. And basically, it's a bunch of shell scripts, and I'll just show you one of them real quick. that uses our Shifra export routine to export the logs of any event emitted by one of the Gitcoin grant related smart contracts for any number of different, or for all of the Gitcoin grants. So this just calls into that for each of the different Gitcoin grants, and it creates both a JSON file and a CSV file containing every event generated by any of these Gitcoin related smart contracts for that address. And then we present it in what we call a data pouch. I don't know why I called it that, but so for each grant, and you can link over to Etherscan here if you want, or you can link directly into the grant thing on the Gitcoin website. We present some information about it. So this is saying this address here has a total of 85 transactions in its entire history, of which 5 were logs related to Gitcoin. This one has 148 transactions in its entire history, of which 33 were related to Gitcoin. And then you can download that data into Excel or wherever you want to. So for this address here, this is every log that was related to Gitcoin. And we can tell that because the Gitcoin grant smart contract generated that event. And this is the event. It was a donation was sent. This is DAI. Here, this is DAI, maybe $1.90 or something like that. It was sent to this address from this address. So for every donation to every grant, you can download any of the data that you want. I'll just show you TrueBlock, and then you can. This I found kind of interesting. So this is the balances of these accounts. So one of these grant accounts has 19,000 Ether in it. Some of them have more or less Ether in it. And I thought this was interesting for people. It's not a real indication of how much money they have, but it's an interesting thing to look at least in my opinion. And then, so that's for each of the individual grants. And then we have, for the 3 Gitcoin smart contracts, we've started to collect the same information. So the Gitcoin grant smart contract has 22,000 total transactions and 46,000 events were generated. And then you can download that into an Excel spreadsheet. Takes a few seconds. So there. So then you get, and this is basically every event that was ever created by that smart contract. And you can do things like sort and search for the donations. And now you can get every donation for every address, showing which token it was for, how much, who it was from, and who it was to. So let me just close that. And I'm doing this because I believe that it's interesting enough to get the data from Gitcoin. That's interesting. But I think it's really, really interesting when people start getting the data directly from the chain. And we do our own analysis of our own selves as a community. And we just, we don't ask permission to get to this data. We kind of have to get to the, I kind of feel like if we don't purposefully choose to know that this data is available, that other people are going to start collecting this data on us and use it against us. So I want us to all know how available it is. And then you can also download JSON data. This is the payout contract. And what happens with the payout contract is, it's easier to see here. What happens is Gitcoin says that there's a payout available to people. and then they say finalized, then they transfer DAI into the smart contract, then they close the round by saying funded, and then individuals can pull their payout out of the smart contract. So one of the interesting things I did is there's 300 and some payouts where Gitcoin made a matching contribution, but there's only been 167 claims, which means there's about 120 claims left to be retrieved from the matching, which I thought was interesting. And this also gives us like all the matching. So this is in DAI. So Gitcoin said this address here deserves that much matching. So it's a way to get the matching. And then this is that address claimed their match here. This was claimed. So my goal is to kind of give us all access to all the data, so that we can all do all kinds of different studies and trying to come to an understanding of what's actually happening. And then I was imagining that this is interesting. This is just the number of transactions per month, and you can clearly see the rounds here. And in this round, we had on the first day, we had this huge spike in activity. And if you look at the previous rounds, it always kind of came later, the higher activity. And I think this is really something interesting to study right here. Like, why did we get so much activity like that? And this is just sort of the tip of the iceberg, because I'm only looking at the number of transactions. I'm not looking at, how much the transactions are for, or what kind of relationship the transactions have to each other, or the donors have to each other. So basically, you guys want data, it's all right here. It's all available. I'm working on automating it so that every block, it updates whatever grants received during that block. So it'll be constantly fresh data. Right now, it's just going to be static data. But within the next couple of days, I hope to have fresh data at every block. So I'm not sure if that's a good thing or a bad thing. It might mess up your analysis. But so anyway, so that's what I'm doing. And I'm going to try to announce that a little bit later this week, hopefully. And I'd really love to have people come and help me with this, because I'm really good at collecting data, but I'm not that great at like analyzing the data once I have it. So if people come and say, I'd love for this data to have this feature or this piece of data, because then I can do my analysis better, I can instantly give it to you, but I would never have imagined adding that unless somebody tells me what they need. So the more you can tell me what you want, the more I can give you. And I'm very happy to do that, because this is the thing I'm building, and if I can get people's feedback, I can build a better tool. So thanks for listening.
Awesome, Jay. Thanks for sharing. I have 2 questions, but I'll let you guys go first.
Yeah, great, Jay. Can you post a link to it? Because there's a tokeneconomics.io, and then I can't find anything.
Where is there a way to post a comment in this chat here somewhere?
Here in this exact chat, not because it's only the voice channel, but please post it to the Gitcoin channel.
Yeah,
so that it's available for everyone.
Yeah, I'm doing that. Yep.
Okay.
It's called tokenomics.io. Yep, it's in there now.
Any other questions, guys?
Well, I think it's really, really that you're doing this, because I agree that sort of any level of independent verification is really good for openness, transparency.
Right.
I
think
agree.
it's really important.
It's great for openness. It's great for educating the community. It's great for user agency. And I guess it's only to the benefits of Gitcoin grants if there's transparency and accessibility for the data for further exploration. Because I mean, the community needs to take informed decision in all kinds of be it the grants, be it other bounty things that are taking place at Gitcoin. I think that's really amazing. So if this would be the only outcome of this research group, I'd already be very happy. So very cool, Jay.
Thanks. I worry sometimes because it's so transparent, this data, that I think people don't realize it. And then when they see just how transparent it is, they kind of say, oh my gosh, that's really transparent. So
yeah, but I think that it's the exact where you mentioned if we are not use it for the purpose of these things, they can be used against it, and we wouldn't even be aware.
That's right.
Yeah, and I think that's something that is mostly underrated. I mean, I'm working on balancer pools at the moment, and this is DeFi and all kinds of market making and trading. And there, of course, we're also using on-chain data to have real-time events and then see how a pool behaves and how robust and stable a pool is. And here, it's already taking place that we have all kinds of bots interacting with the pool, and this human interaction is the tiniest part of transactions that are taking place in a typical decentralized exchange pool. And those bots are certainly optimized with all kinds of measure, and they are building on top of this transparent data available on the blockchain. So I think no way in just trying to let's not be too transparent because then perhaps people might be afraid. No, this is actually taking place. This transparency is leveraged, and we have to make sure that we protect the ecosystems in the same way.
Right.
Two comments on, maybe you can pull up the transactions again. On this claim things, just as a comment, not I don't have the final truth here, but I know that there are always two types of transactions when a grant is receiving the funding payout. One is kind of a test transaction, and the final one is sending the matching funds to the grant. And I have never claimed anything, and this is why I'm a little bit confused by these claim transactions.
Right. I think that is this here. He creates an exact duplicate of his matched of the actual payment contract, and he calls it CLR something. So and he sends a test token, and then he says, "Can you get your test token?" And only then does he send your actual payment to the real contract. So I'm not showing that here. All I'm showing is like the actual payout contract here. So
okay.
Yeah, this only has the, and then what they do is they put, they do a whole bunch of transactions called payout added, and then they, sorry, I'm just scrolling down here, and then they're finished. When they're finished adding all of their payouts, then they finalize, then they put their money into the smart contract, and then they close the round, and that enables people to go and get their money. So this guy here went and got his money right here. And then the next guy came along and got his money or her money. So Gitcoin tells the contract it's ready, closes it, sends the money, closes the round, and then people can pull their money out.
Yeah, and this is what I mentioned. I'm a bit confused about pulling because it never has been an activity on my end in the last
Yes,
5 to 6
it has
months.
to be an activity. It has to be an activity on your end. You have to initiate that transaction.
And we have to check this with Gitcoin Grants. So I'm not sure what's going on there. Okay.
Yeah,
grant subsequently. Do you know what I mean? So to have to look for this back and forth in splitting off contributions.
Yeah, definitely. So our software is actually C. It's written in C++. So for me, what I would probably do is write a piece of code that kind of looks at every grant and then looks at every donor to every grant and then looks again at the next level deep of where all that money came from, and then probably use some of those graphing techniques. But I don't know. That's what I was saying before. I don't know analysis so well.
Yeah, and I would also leave it to Matus then what he feels direction he wants to go to. I just wanted to give everyone a picture of okay, why expanding the data set beyond what we have, beyond pure contributions. That's my the message here from my side.
Right.
Okay.
So maybe just to mention something that I found while researching the Autovec. Like I basically found how it is used at PayPal for solving a similar problem. So it might be just, let's say, interesting to see, let's say, like a similar use case, let's say.
Okay, cool.
Maybe I can share my screen and just quickly show all of this.
Yeah, sure.
Is it okay?
Absolutely.
Perfect. Let's see whether it works. Share your screen. Voila. So this is what I found essentially. So here they explain how they use at PayPal. They use for collusion fraud, and they use representation learning to do this, right? Basically to prevent payment collusion fraud. But like in the end, it's quite similar. They presented this like 2 years ago, or like even more, and they explained the collusion fraud in this case. But I guess this can be used for a lot of different things, right? So just, let's say, mentioning that this technique is used in the industry already, just not that well known, right? And also, let's say, all these things, it's kind of like how colluding, right, in different ways to commit fraud. And let's say it's a very similar type of problem, let's say, if we basically map, let's say, the problem itself to some technique, right? So maybe I can, let's say, share this also like in the Gitcoin chat. It is definitely worth exploring further. Maybe like if somebody thinks so. Yeah, I basically just thought it would be interesting to mention if because yeah, like DJ, you mentioned that the question about the algorithm behind it or the approach, right? And this is, let's say, one that might be useful in this case.
Yeah, it looks great. I think I'll bring the data and you bring the algorithm, and we'll meet for a little working session. How about that?
Sounds good. Sounds good. Yeah, I mean, I will basically just share in the chat and just let somebody else continue. Thank you.
Thank you.
Yeah, I think let's check if I know that there are some people still looking for a dedicated task then to, okay, what could be my deliverable, my contribution to the overall results of this group. So yeah, make sure both of you to share this, and then hopefully somebody can pick it up. I would be glad to have some results here. All right, thanks to you both for sharing this. And now, Andrew, how about the math update?
Can you all hear me?
Yeah, we can. Shall I pull up your slides?
Yes, if you would.
Okay,
Sorry to
give me a
be so
second.
needy.
I'm very glad that Irving is supporting me with the recording again. So there's always something. Okay,
So
there you go.
sort of just a progress report on what we've gotten so far. I've
Mhm.
been discussing with QWERTY a lot, and Dan Lessa and MZ have given it as well. So I've been trying to do three things. Explore the original algorithm geometrically, and I'm really big on understanding the geometry of problems. So that's something I've been trying to bring to this group.
Cool.
And then comparing how the original quadratic funding algorithm and the Gitcoin quadratic funding algorithm are different. And recently we've been exploring how symmetry can be used to make it so to do some. And finally, looking at how it might be possible to implement some known algorithms to solve the problem that is known as the optimality gap.
Cool. And maybe since we have really enough time, everyone feel free to ask questions. So, okay,
So
let's go.
This is the setup we've talked about contributing. And an alternative representation. Sorry, the numbers are so small. Not ideal, but basically we're just taking the edges in the graph and we're converting it into a matrix in exactly the way you would expect. So the edge that goes from 1 to A is going to be in the entry that is under the A column in the 1 row, and that's a really straightforward transformation that's pretty standard. And the hope that's been discussed is that we could use this matrix representation instead of the graph representation, because sometimes matrix representations yield faster calculations. But there's another thing you can do with it, which I wanted to, which is, next slide, please. You can look at what happens if I swap the rows of the matrix, which is not a big deal. It shouldn't change anything. It just changes the order in which you're writing the users. Or similarly, what happened on the next slide if I swap the columns of the matrix, which is not, again, a major change. It's just saying I'm writing the grants in a different order. And these are called row and column permutations. And you can think of them as like your, it's like if you flip a piece of paper over, you're keeping it the same piece of paper, you're just looking at it from a different perspective. And that's what you can do with this. And so this is where the idea of symmetry comes in. If you go to the next slide, please. So when you look at the original quadratic funding formula for the graph that I set up, what you're doing is what's called an optimization problem. And this is literally just the quadratic funding formula that we discussed a few weeks ago. The constraint is saying that the number of total funds given by the users can't increase. So I'm making a change of variable here. I'm calling A1 the square root of the contribution. So then A1 squared is actually the original contribution. I have an 11-month-old colleague.
Yeah, also contributing knowledge.
So this is a really standard, not terrible calculus 3 problem. And if we were in the original quadratic funding algorithm, we would be able to solve this problem very easily. And I think it's worth solving it because it gives some insight, and it also lets us start thinking about other techniques that we might use in the more difficult version used by the Gitcoin grants. So if you go to the next, please. So this is what MZ has talked about as a convex optimization problem. And those are not bad. Those are things that people understand how to solve really well. And so if someone wanted to, and I can do it if no one else wants to, we could try to generate examples and use a Python package cvxpy. And this would give us a data set of different examples of problems that we'd solved. And then we could do some data analysis or look for a pattern that might hold. But unfortunately, but understandably, the original QF algorithm is not what Block.Science and Gitcoin are interested in. They're interested in the modification that's used in the current Gitcoin Grants repository. Next slide. So the big insight that we get from looking at the original is that if you look at the objective function and you look at the constraint function, so you can imagine what would happen if you did a row swap would be something like swapping A1 for A3 and B1 for B3, because you would just be changing the order in which those contributions appeared. And since you're moving an entire row, that corresponds to swapping users. So that doesn't change the objective function, and it doesn't change the. And similarly, if you swap the columns and you look at how the column swaps changes the variables in the objective function, again, swapping columns doesn't change the objective function and doesn't change the constraint. So does that make sense?
Yes.
Okay, and that's huge. That's huge, because now we can look at that symmetry. If you'd go to the next slide. And you can use theory about when problems that have symmetries like this have solutions that are also symmetric. So this is a 1986 article by William Waterhouse from Mathematical Monthly. And if you go to the next slide, I give the huge reveal, which is, ignore the theorem. Like I've translated the theorem into what it means for the Gitcoin Grants case or the quadratic funding case. But basically, if you have an arrangement of contributions and it's not changed by a row permutation, or you have one that's not changed by a column permutation, then that arrangement of contributions will be a local maximum or a local minimum in terms of the collusion strategy. So this means you don't have to do any calculation to find these points. You can instead look for points that have the kind of symmetry that they're preserved under row swaps or column swaps, which is much easier to do. It's much easier to just generate these points than it is to try to solve equations.
But if I may ask, this would mean that we could skip the entire set of simulations that we wanted to find via edge rewiring. We can skip that and can find it via reformulation and finding the local maximum.
In theory, yes, I agree with you. So then if we go on to the next slide, we actually have a harder problem if we actually look at it looks similar, but now we're taking into account the pairwise coordination penalty, which is where this denominator is coming. But the really cool thing is the new objective function, which is harder to calculate, is still symmetric under row and column swap. So next slide, please. So this is no longer a convex optimization problem. This is no longer something where it's easy to pull something out of a textbook. This has now become a quadratic fractional sum of ratios problem, just a way of describing it. And that's bad news from the algorithmic. So if you'd go to the next slide. Sum of ratio problems are, in general, quite hard. I found this 2003 paper that I'm not going to try to say the last names.
Scheible.
Scheible.
It's a German name.
And if you go to the next slide, please. So the abstract of that paper says that sum of ratio problems are basically the hardest problems you. So trying to solve the exact version using existing algorithms is not very promising. If you go to the next. But the good news is if you have quadratic fractional problems for a single function, they're better understood. So it's like the general sum of ratio problems is hard. If you just had one quadratic fraction and you weren't adding them together, that would be easy. And so what does it look like when you have something that matches both conditions? So it's harder than a single quadratic fraction, which is covered in this paper, but it might be easier than a general sum of ratios problem, quadratic fraction structure. That would be the next, please. The bad news is I did a lot of reading about quadratic fraction ratio problems, and it doesn't seem like there is one technique that's well understood that always works. So if we could get someone who is an expert in this specific type of problem, that would probably be. The other problem is, although there are algorithms in literature for this kind of problem, and there are really good Python libraries for convex optimization, I couldn't find any libraries that dealt with this type of problem specifically. So if we're going to have the code, we may have to write it ourselves. And the good news is the symmetric principle still applies. So I agree with Angela's comment that in theory, we could start by generating these symmetric points to generate local and maxima and minima. And that should give us a way to get a handle on global maxima and minima, and we may not even need to write any code to solve anything. We may just be able to write code that generates these points that are invariant for symmetry. So if you go to the next slide. As an example, the problem we're actually trying to solve, I can tell you right away that these three things are going to be local maxes or local mins because they have this property that they're invariant under the row and column permutations. And I didn't have to do any calculation to figure this. I'm sorry, in stage 2, it should be 1 over square root of 6. So maybe I should have done some calculation.
Okay.
So, but again, the symmetry lets you see these are promising points right away without touching a computer or doing any calculation.
And if we would, maybe let's map it to our grants and contributions. Can we briefly look at this and map it to, okay, what would that mean for grants and contributions to define these local max and local minimum?
So, well, the objective is to find, the objective is to determine if a collection of grants or a set of grants and users are colluding. The Block.Science hypothesis is that that will look like a particular set of grants getting an optimum value. And so that would be a global maximum with respect to the function like the one we're looking at here. So this would be if I had 3 users who I suspected of colluding to pump up 2 grants. They would be trying to optimize the problem that's at the top, that function.
Here.
The first strategy would be that all 3 users split their budget. They split the budget of whatever. So I'm assuming here that they have a budget of 1 unit. That's all they can contribute between the 3 of them.
And if we say users here, it's A or is it B, users?
So the users are the subscripts. So A sub 1 would be what user 1 contributed to project. And
to project. It's sometimes
Yeah,
it's the sound is a little bit broken. So A is the contributor and 1 is the grant.
No, vice versa.
No. Okay.
Yeah,
this is the grant.
Yeah.
A is the grant and 1 is the contributor.
Yes.
Okay, thanks.
So, so situation number 1 would correspond to all 3 users giving equal amounts to grant A and giving nothing to grant. And situation 2 would respond to all 3 users splitting their budgets equally between the 2 projects. So they give an equal amount. Each user gives an equal amount to both projects.
And therefore we have 1 fix, okay?
And the third situation would be that they decide to let user 1 give all of the money, and he splits it between projects A. And user 2 and user 3 just give their money behind the scenes to user 1, and they don't make.
Okay.
And so 3, I think, is actually a local minimum. I think 1 and our local. But that's something actually flesh out.
Okay.
Does that make sense to everyone else?
All able to follow here?
Yeah, I'm using some notation that I used in the math working group doc, and I didn't redefine it here. So I'm sorry to put that earlier about what the A sub 1 meant.
Yeah, that's the beauty of the sessions, just in case we are able to ask. And
I have a question. So, if you have 8,000 grants and 23,000 contributors, would you limit this algorithm to 10 or 12 that you suspected of colluding, or are you doing that row permutation and column permutation for all the data?
Yeah, that's a good. Go ahead. So you would restrict to, so the way that Block.Science has proposed is they take the set of grants that are under investigation for collusion, which will make it be a small number of columns, 2 columns. Then
I see.
3 columns, and then you restrict to just the users who gave to those grants, which expands out just a little bit more. And then you expand out to all the grants that they gave to, and then you expand it out one more time to all the contributors who. So you're comparing what the actual allocations were to if there were people who were colluding to optimize this particular subset. So you're right. The actual problem you're solving will end up being much smaller than the full data. You're zooming in on a small network.
So you can identify before doing the actual calculation on the real data, the points where it would be optimal, and then you search, and then you look at the data and see if any of the data goes to those points.
That's probably a better idea. That's a good idea. What's been proposed is that we go sort of collection by collection and solve this. But the size of the matrix is not like, people often use 100,000 by 100,000 matrices in industrial problems. So
I see.
It's doable.
Okay.
It would be better if it were smaller.
okay. Any other questions or comments?
Yeah, Andrew, I heard you mention that if you throw in the pairwise computation, it gets really hard. But I do recall you were saying that maybe we should revisit that formula. Suppose you can ditch that formula and bring up something else to look for collusion patterns. How could you use symmetry to do that, maybe?
So this principle will apply no matter what objective. So my proposal, which I think this would be a better idea. I don't have an objection to pairwise coordination. I think that taking the average of the trust bonuses rather than the maximum of the trust would be preferable. Encourages basically taking the maximum trust bonuses enables a trusted user to create a Sybil attack where they create fake users that collaborate with. And that makes it, taking the maximum makes it more effective than. So if I had one suggestion to change Gitcoin code base. If I were going to make one suggestion, I would say that the average has a measurable effect on the likelihood user implements a Sybil attack, or it removes the incentive for a trusted.
Yeah, or you might even go further with that trust function in order to, if you have one trusted contributor and he is attracting other untrusted contributors, and you do some penalty or something, but you don't, of course, know if that untrusted contributor is really colluding with him. Yeah.
So my proposal would actually be that you average trust all users who have contributed to, and that way, I mean, I don't have the evidence in this place to make an argument for it. I think that would be a better. One reason is it would make the calculation faster because you weren't constantly looking up trust to take the max really pattern. And secondly, would not be. It would tend to dilute them. What you would expect is trusted user, and then users are drawn to that, and all new users by default are untrusted. So
yeah. So maybe are you proposing so ditch the pairwise function with respect to the trust bonus function? Make that more important or something like that.
No, I'm saying that so there are two pairwise things that are calculated. One is the coordination penalty, which shows up in the denominator. And the second is the trust function, and I'm ignoring the trust. And the reason is that the trust function has a small, it's only, from what I'm told, like between 1.0 and 1.4. So ignoring it while you solve the equation, they'll give you a good approach. I don't have an opinion about ditching the pairwise coordination formula, but I think that replacing the trust with an average across all users contributed, rather than weighting it by the more trusted user of each pair, is something.
Not sure if it's only me, but Andrew, sometimes we can't hear you anymore. Is it on your end as well, people?
Sorry.
Yeah.
No problem. I was just wondering if we might try reconnecting because it's super interesting, and so sometimes I miss 20%, let's say, and sometimes it's the decisive 20%. Okay. I guess Andrew is reconnecting. Yeah. Okay. Let's try again.
You hear me better now?
Yeah, at the moment, yes.
Yeah, I have.
Oh no. We can't hear you.
Well, maybe I can type up some of these thoughts and send them out for.
Oh yes, that would be cool.
If you go to the last slide. So one thing that we're kind of overdue on doing is to implement a simple matrix representation of the Gitcoin quadratic funding algorithm. However we do it using matrices should make it faster. And I've asked if Gitcoin has a testing validation suite. I've asked publicly and privately, and I have not been able to find one. So I don't know how they're validating pull requests. To me personally, this is a little bit concerning because it gets back to the transparency thing. Like, there's not an easy way to tell that their calculations are actually implementing what they say they are. And if I'm trying to write my own implementation, there's not an easy way for me to say that I'm getting the same answers they are. Second thing, which I think we can go ahead and do, is use some of these geometric or symmetric principles in conjunctions with computer experiments to help us get more insight into the way that the allocation space is shaped. And I have some ideas about how to do that, and they're based on generating the fixed points to start with, and then doing a little bit more validation. So mathematically, the validation shouldn't be necessary, quote unquote, but of course, in practice, there's a difference in theory and practice. So we might do a little bit more simulation to verify that the theoretical results give what we think. And finally, it would be cool if some of these algorithms that are in papers in Python that would have impact beyond the Gitcoin Grants ecosystem would go further. If they're implemented in Python, in any Python library, I can find them. But that would actually give us sort of the ultimate theoretical validation that our simulations and our geometric arguments, because it would actually solve these equations and give us we would know that we had the right answer for. So that's what I and the other people I've been talking to, this is the result of these.
Okay, not sure. Can you hear me, Andrew?
I can hear you.
Okay. I was wondering, I'm not sure if you're finished. Don't want to interrupt you.
No, I am done.
Okay, cool. Yeah, these 3 working items are really exciting. I mean, imagine if we could get to number 3. And I wonder if radical exchange, certainly you have discussed this with Sargam, if radical exchange might be interested in funding work on the sum of ratios problem. Okay, I have a question on item number 1. It sounds like testing validation suite. It sounds like this here we might be able to draw from established practices somewhere else and mature the crypto sector with having such a testing validation suite. And you seem to have an idea how this should be structured and can look like. Can you expand a little bit on that? I can't hear you. Anyone else able to hear Andrew? Again?
Oh, I cannot hear him.
Okay. And we can't hear you at the moment. Not sure if we want to give it another try and you reconnect perhaps. You seem to be not muted, so this should be fine. Andrew, we can't hear you. Andrew, you seem to speak, but we can't hear you. We can't hear anything. This is awful. Okay, we might need to postpone the answer. I would love to discuss this further. This could be very interesting for many projects. Aha. Let's give it a final try and hopefully Andrew will be able to connect again. All right. Can you hear me, Andrew? Oh, yes, we can.
Can you hear me?
Yeah, we can hear you again.
I think just having a test suite would benefit the project if there isn't. It would certainly make my life easier, so maybe I'm being selfish.
So what would you need here? It's a full implementation of the current algorithm in Python, or what is it exactly?
What we would need is something that is a standard question answer set. So like calculus exercises have the answers in the back of the book. You want a repository where it was like, for this grant, for this contribution network, this grant should be getting this much in funding. And then I can independently implement the algorithm and I can say, yes, I agree, that calculation matches. And then we could also compare, okay, the Gitcoin algorithm takes 10 seconds to get that result. Our algorithm takes 11 seconds, so it's not as efficient. Or our algorithm takes 5 seconds.
Is there any example I should take a look at? Because now I'm wondering, there are at least 3 projects. I would really ask the same question, and I would be really keen if they have something in place. And my assumption is no in crypto. And if I guess this is also a matter of education, and of course it would be cool to point to some examples with a really good solution. Is there anything you've seen so far?
Ethereum has a very good test. Ethereum has a good unit test. And I can find some.
Okay. Because it feels like, I mean, for all kinds of token engineering questions, such validation suite should be a basic infrastructure, shouldn't it?
That's my opinion. But that's my opinion.
Okay.
It would solve the issue you were saying where the numbers didn't match up. People could independently say, well, I got this number and it did match up, or not.
Yeah. All right. Thanks. Anything else? If there aren't any other question, I have a final one, but just want to make sure anyone has enough time to unmute and raise a question. Okay. I was wondering, who's at the moment at the MOF working group? So is there any fixed set of people? And how do you...
So last week it was me, QWERTY, and TJ Rush.
Ah, okay. All right. I got some questions regarding from all directions, not in your group particularly. I got the question, okay, it's super exciting to listen, it's super exciting to observe, but I have the feeling I'm not able to contribute that much. And what should I do, and how then to add to the results? And I think this group here is a great example. Also, all the other results and conversations we're having there, I think making this accessible is a huge portion of the value we can contribute to the overall token engineering community. So, for example, the slides you are producing and nailing and also make the entire process of step by step coming to a result is super valuable. So even the documentation of what's happening is a super valuable contribution. So just in case you're wondering, this is definitely something needs to be done, and I would be really glad to have proper documentation, even of the things that turned out to be not helpful and not relevant. Then also collecting all the libraries, all the links, hints, and these items we've been sharing along the way is also something super relevant. Just on a side note, this is something that is certainly helpful for many other people. And then I think we have only around 2 weeks to go now until this research group is officially coming to an end. So April 2nd is a final presentation. I'm currently discussing with Gitcoin how to make this an open event and we invite the overall token engineering community, the Gitcoin Grants ecosystem, so to make it a little bit larger, but no worries. I know that everyone is still, everything is in progress, but just to let you know and make you aware of, I think we might have 2 to 3 groups with the dedicated research questions, but then a lot of stuff left and right. And I would hope to capture this in these final presentations as well, because this entire process has been really inspiring, and I guess so many learnings for the people in this group, and certainly for the rest of the token engineering community. Okay. Anything else at the moment? Otherwise, I would close this call and we'll meet again on Thursday for a hacking session. And here, I guess, I would be super happy to hack on the machine learning next step. So please let us know if you have meet any other hurdles with compression, Jan, and using the files. Let's sort this out. Make sure it's not a showstopper on your end. And happy to discuss next steps in the math working group, and then take a look at Erwin's topic. Maybe Erwin, if you hear me now, and happy to DM as well, you might provide a summary as well of your topic. And then later on Thursday, we will have another academic session with Sargam and Gitcoin. And there, I guess it would be the chance to raise some of the questions we have discussed now, like how about the infrastructure? How about transparency? How about education? And make also Gitcoin Grants more verifiable for the entire community. That this Thursday is the chance. So let's not miss it. Okay. Any final comments? Then see you on Thursday, and thanks a lot, everyone, for sharing, asking questions. I really enjoyed the session. Thank you for participating.
See you. Bye-bye.
Thank you.
Everyone, ciao, ciao.
Thank you.